Lesson 27, Science 8, and today you're going to analyze how energy systems work. So grab a pencil, today's journal slip, your science journal, and you'll also need the article titled Energy Inventions posted on Schoology. Let's remind ourselves of the problem that we're trying to solve. Going to fast forward just a little bit. Here we go.
Are you okay? Can you hear me?
She's breathing and she has a steady pulse, but she needs to get to the hospital. Call her position.
My battery's dead.
Wonderful. She's fine.
Your battery's drained too.
You can get up now, Anna.
Good thing it's just a test drill, right?
Well, it could be worse. Guess we still have working flashlights.
Okay, the rescue workers complained that the batteries in their flashlights and radios ran out during rescue missions. They need a way to charge their batteries in rescue situations so that they can be sure they always have enough energy for their flashlights and other devices. So how can the rescue workers get energy to the batteries in their equipment during these missions? To answer this question, we need to know how objects, like batteries, get energy. So how does that happen? What claim do you think best answers this question? Do you think that objects make their own energy? That objects get energy from other objects? Or only living things have energy? Mark your choice on your journal slip. To figure out how objects get energy, you're going to read and evaluate the information in the article Energy Inventions. You can find this article posted on Schoology. When you read, I want you to find evidence that would allow you to choose the best claim for how objects get energy. The article is going to present you with two inventions, a little sun lamp and a hollow flashlight. These inventions provide portable light in places where electrical power isn't always available. Reading about these devices can help us figure out how we can charge portable rescue devices when the power isn't available. Pause the screencast now and read the article with the intent to answer the question that appears on the screen. Your goal is to find evidence to support or go against any of the energy claims on the screen. Go ahead, do this now. So did you find evidence? Here, let's go to the last page of the article, and I want us to go to the last paragraph, right here. It says that the little sun lamp and the hollow flashlight have something in common. They get their energy from somewhere else instead of making it themselves. That's true of every object in the universe. This evidence supports claim 2. Make any corrections on your journal slip if you need to. Now, let's think about how the energy gets to the rescue workers' devices. One of the main pieces of equipment that the rescue workers need energy for is a flashlight. What kind of energy does a flashlight give off? Yeah, light energy. But where does that light energy come from? A charged battery. And what type of energy does a charged battery have? Kinetic or potential? Yeah, potential energy. So the potential energy of the battery was converted or transformed to light energy in the flashlight. We can represent that energy transformation with an arrow. So our energy transfer diagram shows that energy is being transferred from the battery to the flashlight and being transformed from potential energy to light energy. Nothing creates energy or destroys it. If something has energy, the energy must have been transferred from something else. So the battery doesn't create energy. It must have been transferred from somewhere else. Part of our challenge is to find the best way to transfer energy to the rescue workers' batteries. Now, let's think about the two energy inventions from the article and create some energy diagrams. How does the hollow sun lamp get its energy? Take a moment to think about how energy is being transformed and transferred to create light energy. You probably need to go back to the article. That's right. Pull out the article and find evidence that will help you create the energy diagram for this device. Do this on your journal slip now. It's really important that I can see evidence of your thinking first. You're going to have a chance to make revisions in just a moment, but I want to see what you were thinking first. Okay, in the article, it said that a solar panel on the back of the lamp converts energy from the sun into potential energy that can be stored in a battery. And this energy is transformed into light energy that makes the bulb shine. Now, what about the hollow flashlight? Can you create the energy diagram? Go back to the article, gather evidence for how the system works. Again, I want to see evidence of your thinking first. Okay, thermal or heat energy from the human hand is converted into electrical energy, which then powers a light bulb. The hollow flashlight doesn't have a battery or even an on-off switch. It lights up as soon as a user picks it up. Now, thinking deeply about the problem we're trying to solve can help us come up with the best solution. For an energy source to be useful to the rescue team, it needs to be available to transfer energy whenever energy is needed and to transfer enough energy for the device to work. The rescue team is considering using sun or solar cells or human-powered generators to get energy to their equipment on rescue missions. Just so that you know, generators are machines that transform kinetic energy into electrical energy. Which energy source do you think is the best for the research team? To help make your decision, I have some available evidence. These evidence cards are also on the last page of your journal slip. I want you to review the evidence carefully so you can craft an argument. Begin with your claim, include appropriate evidence from the cards to support your claim, and use science terms like energy, transfer, transform, potential energy, kinetic energy. Develop your argument on your journal slip first, and then take that argument to the larger classroom discussion board so that we can evaluate each other's ideas. When you're on the discussion board, make sure to post a well-crafted stance and then respond to a classmate. So far, I've really enjoyed the discussions occurring on the discussion board. As you respond to a classmate, make sure to key in on a specific part or parts of their argument. Our thinking is only going to move forward as we push back on each other's ideas. Remember, the problem that we're discussing is a real-world problem and is playing out all over the globe, as many parts of the world are underdeveloped and could really benefit from such energy devices. Your thoughts now could lead to some pretty innovative thinking later on. Don't ever underestimate the power of an argument. All the Science 8 teachers, including myself, are very proud of you, each and every one of you. You should know that. Until tomorrow, keep thinking, keep learning, and keep holding yourself to a high standard.